The last part of the Singapore framework for VCD also talk about the collaboration periods. Essentially, intensive collaboration period, or in short, we call it ICP, and progressive collaboration period, or in short, we call it PCP, are activities in the project schedule that incorporates all functionality you will perform under the area of coordination works, but it is complemented within the Vdc framework. The Vdc framework provides the foundation and basis for carrying out the ICP and the PCP. Essential understanding of how to carry out effective integrated concurrent engineering, or in short we call it the ICE sessions, planning and managing processes, as well as creating meaningful and measurable metrics, are just some of the key elements towards getting the best result out of VDC for the project. Below are some of the 4 key principles of ICP and PCP. Firstly, the ideal coordination setup is to physically co-locate all the key stakeholders and address issues as quickly as possible. But since physical co-location may not be feasible most of the time, a variation is for stakeholders to convene on a very frequent basis, especially at the beginning of the project, using integrated concurrent engineering, or ICE, to collaboratively resolve any issues resulting from the project BIM coordination and validation. For projects that do not have the luxury of a dedicated backup period after project award, the intensive collaboration period may still occur during site preparatory works or early stages of the construction, since issues must be systematically addressed by order of priority according to the master schedule critical path. Lastly, the main difference between ICP and traditional coordination is that issues are raised, resolved, and updated within the BIM model as much as possible during each ICP session. Issues covered during ICP or PCP sessions are not just limited to matters raised by the consultants, contractors, or subcontractors, and it may typically include the following. It could be modeling issues, it could be design-related issues, it could be clearance and accessibility issues, it could be working space issues, it could be resources, processes, and methods that will be of concern to any stakeholders, which will require clarification amongst the team. It could be depending on the agreed scope of work in the ICP. Temporary works may also be covered, or any other issues surfaced over the course of the discussion. During these ICP and PCP sessions, the BIM model will be used very extensively, and we need to ensure the following are carried out. Firstly, intra-disciplinary quality checks. This is where you ensure the quality information in the elements of the project BIM they are developed. Some examples of these checks you will perform include no overlapping or duplicate of elements, no floating items that have no spatial relationship to the surrounding. Extended quality control checks can include serviceable space, where you want to ensure accessible space are not interfered with other building elements. The second area will be the interdiscipline coordination check, typically carried out across discipline or multiple project BIM content. Some examples of this check could be to ensure consistent representation of structural columns between the architectural and structural project models, or that there are no crashes between the windows and the structural beams. And also you will look into the essential core information. Beyond creating geometrical representations of the beam elements, embedding essential core information, can help improve downstream activities. For instance, whether a particular column is precast or cast system 2, or whether a cable tray is for electrical works or telecommunication. In any case, it can speed up the understanding of the project in planning and decision making. In today's conventional practices, one will have to clarify with consultant or based on local knowledge or assumption. All this could lead to delays or rework. Typically, the ICP and the PCP sessions are carried out in the form of an integrated concurrent engineering session, or we call it the ICE session. In order to create an effective ecosystem for the ICE session, these are some of the things that we will have to go through or think about. Firstly, all respective stakeholders must have appropriate representatives for the purpose of solving project issues virtually before approving any actual downstream works. Stakeholders are expected to ensure that the right representatives are present for any of the decision making, for instance, design architect or the structural engineer, in accordance to making decisions that affect the architectural model or the structural intent. All stakeholders must contribute effectively to address matters raised during the ICP or the PCP sessions. Any stakeholders, for example, landscape consultants or specialist subcontractors, who may not have their own BIM modelers, they are still expected to participate in these sessions. This is because any item that has implication to their work or vice versa must be addressed together as a team, so that consistent interpretation is communicated to all members. The BIM modelers or BIM coordinators, they are expected to be present to make any changes on the ground based on discussions and the outcome of the ICP or the PCP integrated concurrent engineering sessions. Ideally, all stakeholders use the same or interoperable software platforms, and they must have reasonably qualified, skilled staff to carry out their own scope of work. The ICP or PCP moderator will have to be mindful of the targeted incidents to resolve and put in the effort to ensure that the meeting is going on track. Stakeholders involved during the ICE sessions in these ICP or PCP phases, they are either active participants or passive participants, depending on the criticality of their role during their discussion, and also according to what phase of the project is being addressed at that point of time in the master schedule. That is why at certain times the roles may change from active to passive, or even passive back to active for certain stakeholders. For the active participants, they hold a primary role in all discussions as their input is critical. They are usually represented during most of the ICE sessions. Passive participants may still be needed to be involved during the sessions in the event that the issues discussed or involved affect their scope of work or vice versa. ICP and or PCP will eventually result in changes to the way the project gets delivered. The change process is essential to realize overall productivity gain and quality improvement for the project. The primary concept of ICP and PCP is to bring forward as much of the coordination work as possible early in the cycle so that downstream activities can get realized and executed predictably over the project lifetime. It is also to minimize redundant and unnecessary work as much as possible. For instance, effort and time to prepare documentation for construction works based on non-federated BIM could be wasted if constant changes were expected out of it. Unfortunately, these changes may not be eliminated 100%, though we can minimize instances as much as we can. Below are an example of what the change process means to the project cycle. In a conventional approach, when a project gets awarded to a contractor, the contractor would rush to generate drawings for downstream activities as early as possible. Over the course of these activities, revisions and changes could flow through due to a number of requests for information raised. With more generated and different versions to different disciplines, coordination work then becomes more complex. In some cases, using wrong set of documentation for construction could result in delays or rework. With the ICP and PCP in place, the system will require a blackout period where no drawings are to be generated until all coordination works are virtually assessed and verified good for construction for that particular area. This is in line with the concept of VDC, where we are building twice. Remember, firstly, we are going to build our project in the virtual world and then use the model to solve or to resolve all the problems. And then the second time we build, we are going to build it in the physical world. This approach is usually pegged to the master schedule, where high priority items are worked out on first. In addition to this, metrics can also be compiled to measure effectiveness of the virtual construction against the actual physical construction. The following are examples of metrics that may be used to track project performance during ICP and PCP. These metrics will be monitored frequently during the period to evaluate whether or not targets are reasonable and also to improve overall performance and productivity. Number 1, issue progress tracking. This project team sets a target to the number of issues to be resolved in each integrated concurrent engineering session and keeps record to the number of open versus closed, as in the matrix. Number 2, issues turnaround time. When issues remain open, the time taken to close them is tracked. Should the figure exceed the target turnaround time, necessary actions must take place. The targeted duration can be set according to the complexity of the issue. Number 3, plan against actual construction. Tracking plan versus actual variance in a construction task against a target can help to monitor the productivity performance in the project. Number 4, Icp Pcp Session Attendance. Any essential party missing in the session can delay resolution of the issue. As such, monitoring this against the expected representatives' presence is important for the project. And you can see here some graphical examples of the targets and the performance measurements, including issue progress tracking, this attendance of the sessions, the issue turnaround time.